Hello students, welcome. Today we want to do 2023 Kcse chemistry PP1 prediction. As you know, PP1 chemistry has got several questions, like it can have 29 questions, 28 questions, 30 questions, 31 questions, and something like that. So I want to start with question number 1. And in question number 1, we have the diagram below shows part of the Solvay process. So this is a chart or a part of Solvay process. If you remember Solvay process, we were having some raw materials. Some of the raw materials include brine, it includes ammonia gas, it includes carbon dioxide gas, and we have also coke and also limestone. So here we have solid Y. This solid Y is taken to chamber K. So this is limestone. When it's taken to this kiln, it is decomposed or it is heated to produce carbon dioxide and also calcium oxide. So this solid P is calcium oxide. We say this solid Y is calcium carbonate or the limestone. Okay, so in this chamber M, we have brine taken to chamber M with the ammonia, and we are having carbon dioxide from the kiln or chamber K going to chamber M. So chamber M is just the Solvay tower or the carbonator. So the product will go to chamber N. So this is the filtration chamber, and we are having ammonium chloride solution and also sodium hydrogen carbonate, which is solid. So to see the questions, we are told name solid B. Solid B is this, and we have seen it's calcium oxide. So the answer is calcium oxide. So next, we proceed to part B of the question. And part B of the question, we are told state the process taking place in chamber N. So if we go back and see chamber N is after the Solvay tower, and that's the filtration chamber. Here, we are separating ammonium chloride from sodium hydrogen carbonate. So we can use two processes. One is filtration method or filtration process, or we can do fractional crystallization. That's the answer. So but C, we are told state two uses of calcium chloride, which is a byproduct in this process. So calcium chloride is used as a drying agent. Remember, in chemistry form 1, we have learned the drying agents. There were 3: concentrated sulfuric acid, anhydrous calcium chloride, and also calcium oxide. So calcium chloride is used as a drying agent. Number 2, it's used in the extraction of sodium metal by the Downs process in the Downs cell. So number 2, we are told 100 centimeter cube of methane gas diffused through a porous partition in 40 seconds. How long will it take 90 centimeter cube of ozone gas to diffuse through the same partition? Then in bracket, we are given the relative atomic mass of carbon to be 12, the relative atomic mass of hydrogen to be 1, and the relative atomic mass of oxygen to be 16. The question carries 3 marks. So we are going to do rate of diffusion. So we have two gases here. One is methane gas. We know it is volume, and we have it is time. So in this side of ozone gas, we have the volume and we don't have the gas, I mean the time. We are asked to find out the time. So we have several formulas, but know that the volumes of methane and ozone are not the same. So the first step, we can do the volume to be the same. So before that, we have done this. So we're having the gas methane. Its chemical symbol is CH4. The relative molecular mass, RMM, will be 16. 12 for carbon, 1 times 4 for hydrogen, that will be 16. The volume is given 100 centimeter cube, and the time is given 40 seconds. Ozone is written O3. Then the relative atomic mass of oxygen is 16 times 3. We are going to get 14 as the relative molecular mass of ozone. Then the volume of ozone is 90 centimeter cube, and we don't have the time. So first of all, we want to make the two volumes to be the same, the volume of methane and the volume of ozone. So we have the volume of methane and also the time for methane. So we can say, what if 100 centimeter cube of methane is having 40 seconds. What if we make 9 centimeter cube of methane gas? What time will it have? We cross multiply. So here we are going to get 90 times 40, 90 times 40 divided by 100. That means it will have 36 seconds. So that means when methane is having 9 centimeter cube as it is volume, that means the time that it will diffuse will be 36 seconds. Okay, so therefore we can have the formula to relate the relationship between time and also molecular mass. Here we are saying time of ozone divided by the time of methane will be equal to the square root of the molecular mass of ozone and also the molecular mass of methane. So we don't have the time for ozone. It's the one that we are looking for, divided by the time for methane. The time for methane is 36. We are not taking 40 because remember we have made the two volumes to be the same. So if we make 90 centimeter cube of methane, the time for methane will be 36. So we're going to have 36 there. It will be equal to the square root of the relative molecular mass of ozone, which is 48, divided by the one for methane, which is 16. So time of ozone will be equal to, here we are going to get the square root of 3, then we multiply times 36 there, times 36 there to remove the denominator there. So time of ozone will be equal to 62.4 seconds. That will be the answer, the time for ozone. Next we go to number 3. In number 3 we are told ammonia is produced in large scale by the Haber process. Remember we are done large scale manufacture of ammonia, which is done by the Haber process. We had raw material there. The raw material were nitrogen gas and also hydrogen gas. Write an equation for the formation of ammonia gas. So we are going to have nitrogen gas plus hydrogen gas. We get ammonia gas. So to balance the equation, we have to put 3 there. We have to put 2 here to balance. 2 nitrogen, 6 hydrogen, 6 hydrogen. Then next we are going to go Romeo 2. State 2 optimum conditions for obtaining a higher yield of ammonia in the process. So the optimum conditions, we can take it, it is 2. We can talk about pressure side. We can use pressure of 200 to 500 atmospheres. We can take pressure, temperature of 400 degrees Celsius to 500 degrees Celsius. Then after that, we are going to go to the next question. That's question number 4. So question number 4, we have flow chart. We are told the scheme below shows some reactions starting with Aden gas. Study it and answer the questions that follow. So Aden is here. When you add reagent M, we are going to get this compound. Then if you take 1 mole of hydrogen bromide gas, we are going to get substance X. If you add hydrogen gas here, and we have a catalyst there, platinum catalyst, you are going to get this compound. So if you take this compound and you add concentrated sulfuric acid, we are going to get substance N. Okay, let's see the questions. So part A, we are told name substance X. So substance X is here. We are having Aden. Then we have added 1 mole of hydrogen bromide gas. So how do you write Aden? If we open the structure, Aden is like that, the way we see here. Then if I add hydrogen bromide, what will happen is addition reaction will take place. So what are we going to get? This, we are having only 1 mole of hydrogen bromide. The triple bond breaks up and we are going to form double bonds. So we are going to have more spaces there. So initially we had only 2 hydrogen, this hydrogen and this hydrogen. So now we are adding hydrogen and bromine atoms, hydrogen and bromine atoms. So this is the structure for that substance X. So what is the name of this? So this is, we're having bromo or 1 bromo ethene, because we are having 2. So we're going to say bromoethene, or you can say 1 bromoethene, one and the same, no problem. So we are supposed to look again substance N. Substance N is here. We have ethene. If you have ethene, Then you are told react with sulfuric acid, concentrated sulfuric acid. So the first step, what will happen is the double bond breaks up. When the double bond breaks up, we are going to get single bonds. So initially we had four hydrogen, 1, 2, 3, 4. So in sulfuric acid, we can put 1 hydrogen in this carbon, then we can put the remaining. The remaining will be 1 hydrogen and also sulfate. Yeah, because we're having here 2 hydrogen, 1 I've placed it there, then the remaining hydrogen is here, and also the sulfate is there. So to name this, we have 1, 2, that's 2 carbon, then 1, 2, 3, 4, 5. That's 5 hydrogen. That's called ethyl. It is ethyl. Then here I'm having hydrogen sulfate. So the substance N, its name is ethyl hydrogen sulfate. That's how you can get the answer. Okay, but B, we are told name reagent M. We are supposed to look for reagent M. So if we check reagent M, we don't know reagent M, but we have ethyl first of all. So we can check from there. This is ethyl. Then they have added something which we don't know. We are looking for it. What we have gotten was looking like that. So we are having 1 carbon having 1 hydrogen, and it's having bromine. This is hydrogen, this is bromine. It's linked to another carbon with 1 hydrogen and another bromine. So if you check now, carbon is having a valence of 4, so it's going to have 4 strong covalent bonds. So I have only 1, 2, 3. So to make it 4, that means in between these 2 carbon atoms, there was a double bond. So this carbon is having 4 bonds, 1, 2, 3, 4, as well as this other carbon, 1, 2, 3, 4. So that means if I balance the equation, I was having 2 carbon, I have 2 carbon, I was having 1, 2 hydrogen, I still have 2 hydrogen. So that means what was missing here was bromine molecule or bromine gas, like that, bromine. So that means the reagent M that I'm asked was bromine gas or bromine. That was the answer, because this is just addition reaction. You said alkenes and alkynes have addition reactions, while alkenes, they have substitution reaction. So what's addition reaction? It's a reaction in which one molecule adds to another to form a single product. So in part C of question number 4, we are having ethene undergoes polymerization to form a polymer. Give an equation for the reaction and name the product. So the equation, this is how ethene is written. Ethene can react with another ethene to form a product called polyethene or polyethene. So how are we going to write the equation? Ethene plus ethene. Then how many carbon were you having? 4 in total. These are the 4. So in between each carbon, we are going to have single bond. So initially, I had 4 hydrogen on this ethene, another 4 hydrogen on this ethene. 1, 2, 3, 4. 1, 2, 3, 4. To add, it's 8. I have 8 hydrogen, 8 hydrogen total. 4 plus 4. Then as well, on the product side, I have the 8 hydrogen. So that's how the equation is written. Then the name of the polymer is polyethene, or you can say polyethene. Polyethene. So in case you're asked even to do the polymerization for propene, you'll just write like that. Propene plus propene, you'll get polypropene. Okay, we got to question number 5. We are told the curves below represents the volume of carbon dioxide gas evolves once 2 molar, that's concentrated hydrochloric acid, was reacted with 100 gram of powdered calcium carbonate. And also when 1 mole concentrated hydrochloric acid was reacted with the same quantity, of the carbonate. That means with the 100 gram of the powdered calcium carbonate. So that's how the graph look like, or the curve look like. So Romeo 1, we are told which of the 2 curves represents the reaction of 2 molar concentrated hydrochloric acid with the powdered calcium carbonate. Give a reason. So we have 2 curves here, curve B and curve S. So we were having one with the 2 molar hydrochloric acid and the other one with 1 molar hydrochloric acid. Then they were reacting with the same quantity of powdered calcium carbonate, which was 100 grams. So that means we are dealing with factors affecting the rate of reaction, and the factor that we are considering here is the concentration of the reactants. In our case, the concentration of the hydrochloric acid. So the concentration is higher when it's in 2 molar than when it's in 1 molar hydrochloric acid. So that means the reaction will be faster when we're having 2 mole, and the curve will be sharper. So that means it is B. The answer is B. The answer is B. And the reason is we are saying the concentration of the acid is higher, which has a high number of effective collision by unit time. Hence, faster rate of reactions. Faster rate of reaction. So, Roman 2 of question number 5, we're told, why do the two curves flatten at the same level of production of carbon dioxide? We are saying the quantity of calcium carbonate was the same. Remember, they have given us 100 grams of the powdered calcium carbonate. Hence, they produce the same amount of carbon dioxide. Remember, we are told if one of the reactants are consumed, the rate of the reaction stops, or the reaction comes to an end. So, if the concentration of the acid is higher, that means the reaction is just faster, but it will produce the same amount of carbon dioxide, or the same volume of carbon dioxide. So question number 6, we are saying study the equilibrium, the following equilibrium equation. We're having 2 moles of X gas plus 1 mole of gas Y. Then in the state of equilibrium, we are going to get 2 moles of the compound of X2Y, which is a gas. And we are told this reaction is exothermic because of the negative enthalpy change. So we are told, suggest 2 ways of increasing the yield of X2Y. That's the product. So we can talk of, first of all, a factor, or remember, factors that affect equilibrium. It includes temperature. So this is an exothermic reaction. So if you're having an exothermic reaction, increasing the temperature favors backward reaction because it is exothermic reaction, but decreasing the temperature in an endothermic reaction favors forward reaction. So that means if we decrease the temperature or lowering the temperature favors the yield of X2Y, which is our product side. Number 2, the second factor that we can see here is pressure, because all this is gas. Remember we said pressure affects equilibriums or reactions which are one of them, or which are dealing with the gases only. So increasing pressure, we said, favors the side with low molecules. So here, if we check the number of molecules, we have 2, and here we have 1. That's 3. And on the product side, we have only 2. So that means if we increase the pressure, it favors forward reaction or the yield of X2Y. So increasing the pressure is another way of increasing the yield of X2Y. Next, we go to question number 7. We are told the table below gives some elements in the periodic table. Use it to answer the questions that follow. The letters do not represent the actual symbol of the elements. Okay, we're having A, B, C, D, and E. The atomic number of 12, 13, 14, 15, and 16. Remember, these are elements in the period 3 elements, because it's 12, 13, 14, 15, 16. If you check, we are having 3 occupied energy levels, all of them: 282, 283, 284, 285, 286. Okay, that's what they are common. We are told which of the above elements represent, but a metallic element which forms ion with the smallest ionic radius. Explain. If they say smallest ionic radius or smallest atomic radius, it will be one and the same, because they are talking about a metallic element, a metal. So what do we know about metals? Both the atomic radii and the ionic radii of metals increases down the group when they're talking about a group. But here we are dealing with a period. That means they decrease across the period. So here we're having 12 and here we're having 13. These two are the ones that are metallic because they can donate electrons. These ones are non-metals, C, D, and E. So we have to choose one of these. So we are told with the smallest ionic radius. So what have you said? The ionic radius of elements in period 3, we say they decrease across the period. So that means A is having the highest ionic radius, B is having the smallest ionic radius. So we're saying B. Reason? This is because B has more protons, hence a stronger nuclear charge, hence has the smallest ionic radius. So in part P, we are told a non-metallic element with the largest atomic radius, and we are supposed to explain. So we are saying it is C. The non-metallic elements are from C, D, and E. They are talking about the atomic size. Atomic size is just the atomic radius. Then the formula is the same. We said the atomic size of elements in period 3 decreases across the period. That means the non-metal side, we are having element C, which comes faster to have the largest atomic size or atomic radius. So you're saying C. It has few number of protons, hence weaker nuclear charge, thereby larger or the largest atomic size. Okay. Question number 8. We are having the diagram below shows a pan in JUCO. Study it and answer the questions that follow. We are having region A, region B, and region C. Okay, part A of that question A, we are told write the equation for the reaction taking place in region A. If you check region A, it is up here. And up here, we had carbon 2 oxide, or the reaction starts from the bottom. But C, in part C, we have coke or carbon solid reacting with oxygen gas, giving us carbon dioxide gas. So that carbon dioxide gas will be reduced in part P by the coke to produce carbon 2 oxide. Carbon 2 oxide gas. To balance the equation, we put 2 there. Then in part A, the carbon 2 oxide gas will react with the oxygen to form carbon dioxide gas. So we are supposed to balance this equation by putting 2 there. So those are the equations that occurs in the JUCO or in a burning JUCO. Okay, so we're having 2 moles of carbon 2 oxide gas plus oxygen gas, giving us 2 moles of carbon dioxide gas. Name the gas produced in region B. The gas produced in region B, the way you see here, is carbon 2 oxide gas. Carbon 2 oxide gas. We have written there. Then we are told state one use of the gas named in B above. We are saying, what is the use of carbon 2 oxide? It's used as a reducing agent in the extraction of some metals from their oxides. Like, for example, that iron or zinc. Okay, number 9. Question number 9, we are told study the diagram below and answer the questions that follow. We have tap water, air aspirator, we have tube K, and we have solid X, we have tube M, and we have copper tanning, which is heated in a combustion tube. So the first question, we are told what is the purpose of passing air. So Roman 1 of the question is asking us, what is the purpose of passing tap water through the air aspirator? So the reason is in order to drive out air. So Roman 2 of the question, we are asked to state and explain the observations that will be made in tube M after some time. And tube M is we're having copper tanning. Okay, here we are saying brown metal turns to black. Reason? Copper metal reacts with oxygen to form black copper 2 oxide. So that's the end of that question. The question number 9. We are going to go to question number 10. We are told 15 grams of sodium chloride was dissolved in 120 centimeter cube of distilled water. We are asked to calculate the concentration of the resulting solution in moles per liter. We are given the relative atomic mass of sodium, which is 23, and the relative atomic mass of chlorine, which is 35.5. So we have to start with the RFM of sodium chloride, which is 58.5. It's written NaCl. Na is for 23, Cl is 35.5. So moles of sodium chloride, moles is given by mass over molar mass, or RFM, relative formula mass. The mass of sodium chloride given is 15 grams divided by the relative formula mass, which is 58.5. We are going to get 0.2564 moles. So there are several ways of getting molarity. We are going to do only this moles times 1000 over volume use, because you can also use concentration or mass in grams per liter over the RFM to be the formula for calculating molarity. So the moles is, we have gotten now 0.2564 moles multiplied by 1000 divided by the volume given, which is 120 centimeter cube. So here we are going to get our answer to be 2.136 moles per liter, which we can otherwise even write 2.136 m capital letter mole. Okay, question 11, we are told state the Boyle's law. We are saying it states that the volume of a fixed mass, the volume of a fixed mass of a gas, or the volume of a given mass of a gas, is inversely proportional to this pressure at a constant temperature. So, but P, we are told the volume of a gas at 30 degrees Celsius and 740 millimeter mercury is 400 centimeter cube. What will be its volume? What will be its volume at 50 degrees Celsius at 600 millimeter mercury? So here we are supposed to have our data like this. Volume 1 is 400 centimeter cube. Pressure 1 is 780 millimeter mercury. Temperature 1 is 30 degrees Celsius. So we have to convert it to Kelvin by adding 273. We get 303. Volume 2 we don't have. It is what we are asked. Pressure 2 is 600 millimeter mercury. Then temperature 2 is 50 degrees Celsius given, but we have to add plus 273 to convert it to Kelvin, which we are going to get 323 Kelvin. So the formula for calculating or for dealing with the combined gas law will be V1 B1 T2, which will be equal to V2 B2 T1. So we just take volume 1 to be 400 multiplied by 780 millimeter mercury, which is our pressure 1, multiplied by 323, which is our T2. Then this will be equal to V2, which we don't have, times 600, which is our B2, multiplied by 303, which is our T1. So for us to get V2, we have to divide here by 600 times 303. Then we divide here 600 times 303. Volume 2 will be 554.32 centimeter cube. That will be our volume. So in question 12, we are told sulfur exhibits allotropy. What's allotropy? So allotropy is the existence of an element in more than one form in the same physical state. But B, we are told name the two allotropes of sulfur. That's monoclinic sulfur and rhombic sulfur. So but C, we are told sulfur powder was placed in a refrigerating spoon and heated on a Bunsen burner. Chromia 1, we are told state the observations made. So the observation that we are going to see here is sulfur burns with a blue flame, forming white fumes with a shocking smell. That's the smell of sulfur peroxide gas, because when sulfur burns in oxygen, we are going to get sulfur peroxide gas. So, but Romeo 2, C Romeo 2, we are told the product obtained was dissolved in water. Comment on the pH of the solution formed. So we said when sulfur burns in oxygen, we are going to get sulfur peroxide gas. When sulfur peroxide gas is dissolved in water, we are going to get sulfuric 4 acid, which is an acid. So we are going to comment by saying the pH of the solution will be slightly acidic. Okay. Question number 13. Question number 13, we are told 0.318 grams of an oxide of metal M was completely reduced by hydrogen gas to 0.254 grams of metal. What is the empirical formula of the metal M? Then we are having here M to have 63.5, and we have oxygen, which is having the relative atomic mass to be 16. So first of all, we have to get mass of oxygen by subtracting the mass of the oxide from the mass of metal M. So we are going to get 0.064 grams. So the elements that we are going to have here will be M, it will be M and also oxygen. The symbol here we are going to have M and also oxygen. So the mass for M will be 0.254, it is given here, 0.254 grams. Then the mass of oxygen we have gotten here, 0.064 grams, mass of oxygen. So next we have to go and get the RAM of M, which is 63.5, it's given in the bracket. Then the one for oxygen is 16, it's given in the bracket. Next we have to go to get moles. Moles is given by mass over molar mass. Here we are going to get 0.004 moles, and here we are going to get 0.004 moles. The next we have to go to get mole ratio. The two are the same moles, so we'll just say 0.004 divided by 0.004. We are going to get 1, and on the other side of oxygen we are going to get 1. So next step we have to write the empirical formula. The empirical formula we are going to write here M1, we don't write 1, then O1. So we are going to write M1, we don't write 1, O1, so we don't write 1. So we are going to have MO to be the empirical formula of the oxide or metal M. Next we are going to go to question 14. We are told, given the following reagents: solid sodium carbonate, water, solid lead 2 nitrate, full stop, describe how a sample of lead 2 carbonate can be prepared in the laboratory. So here, check, we are given sodium carbonate, and here we are given lead 2 nitrate. So first of all, we have to add water, then we are going to dissolve the two solutions, then we are going to get the lead 2 carbonate. So we are going to say add water to both solid lead 2 nitrate and solid sodium carbonate to form lead 2 nitrate solution and sodium carbonate solution respectively. Full stop. Then we have to add lead 2 nitrate solution to sodium carbonate solution. Full stop. Filter the mixture to obtain lead 2 carbonate as a residue. Then after that, we wash the residue to remove any traces of the sodium nitrate solution. That's how we are going to prepare that lead 2 carbonate. Question number 15. We are told the volume of liquids can be measured using pipettes, measuring cylinders, or burettes. Explain which one will be the best for measuring 29.1 centimeter cube of liquid. So we are saying measuring cylinder. Why? Because measuring cylinder is used for measuring larger volumes like 29.1 centimeter cube of liquids, as it provides a good balance between accuracy and ease of use for volumes in the range of 10 to 100 centimeter cube. So remember here we have pipettes and burettes, and remember we said they were some apparatus that are used to accurately measure volumes of solutions. Those include syringes, pipettes, burettes, volumetric flask, and so on. So we're saying here pipettes and burettes are more suitable for precise measurements of smaller volumes, like maybe something to do with the 5 centimeter cube or 4.3 centimeter cube, smaller volumes. Or they are used for titration experiments when we are sucking solutions, or using a pipette filler, or when we are dealing with the burettes to put the solutions. Okay, we got question 16. We are told study the information in the table below and answer the questions that follow. We have substance V and W. The solubility in gram per 100 gram of water is 126 in V, and W is 2. This shows that W is more soluble in water than that V. So we are told describe how a solid sample of substance V could be obtained from a solid mixture of V and W, 2 marks. So you're saying add water to the mixture and stir, so the W dissolves because its solubility is 2 grams, can dissolve completely, while solid V does not dissolve. Filter the mixture to obtain solid V as a residue. Then we rinse the solid or the solid residue or that V with some water to remove any traces of solution W or any traces of W. Okay, number 17, we are told use the bond energies given below to calculate the heat of reaction for hydrogen gas plus chlorine gas, giving us hydrogen chloride gas. So this is bond breaking and bond formation energies. We have to use that to calculate the heat of the reaction. So we start with bond breaking. So bond breaking occurs on the reactant side. On the reactant side, we have hydrogen gas and chlorine gas reacting. So it's hydrogen to hydrogen bond with the 435 kilojoules per mole as the energy content, and we have chlorine to chlorine with the 243 kilojoules per mole. So if we sum up, we are going to get 678 kilojoules per mole. So bond breaking is endothermic, so we are going to put a positive sign there. So we go BAV, bond formation energies. So this one occurs on the product side. Here we have hydrogen chloride gas. So we have 2 of hydrogen to chlorine bond. So 2 times the bond energy for hydrogen to chlorine will be 431. We multiply, we are going to get 862 kilojoules per mole. So bond formation energy is an exothermic reaction, so we are going to have a negative sign. So if we want to get the heat of a reaction, the formula is bond breaking energy plus bond formation energy. So we are going to have plus 678 plus, then in bracket, bond formation side, we have negative 862. To put this one in the calculator, we are going to get negative 184 kilojoules per mole. That will be the heat of a reaction. So question number 18, we are told the pH of a soil sample was found to be 5.7. That's acidic. An agricultural officer recommended addition of lime or calcium oxide. But we are told state 2 functions of the lime. So it has 2 functions. 1, to raise the pH of the soil, making the soil less acidic. Number 2, to improve the soil texture. But B, we are told give the name of the process applied in A above. So that's called soil limbing, or you can say limbing. So we go to question number 19. In question number 19, we are told the electronic configuration of ions X2 plus is 2.8, while that of ion Y minus is 2.88. So I told write down the electronic arrangement of atoms X and Y. So we start with X. X here is 2 plus. 2 plus means it has already lost 2 electrons. So we are going to have 2.2.8.2. That's when it's atom. So when it undergoes ion formation, it loses 2 electrons to form 2.8. That's why we are going to have X2 plus. Okay, then Y, here we're having minus. Minus means it has gained 1 electron. So if it has gained 1 electron, initially it had 287. So that's the electronic configuration of the atom. So, but B, we are told compare the atomic radii of the 2 elements. If you check the 2 elements, they are not in the same group, they are in the same period because they have the same occupied energy levels. So if we compare the atomic radii, what have you said about the trend in the atomic radii or atomic radius of elements in period 3? We said the atomic radii decreases across the period. So that means if it decreases across the period, we can say element X has a higher atomic radius than Y, or we can say Y has a smaller atomic radius than X. You can say like that. Then we go part C. In part C, we are told give the name of the chemical family to which X or element X belongs. So if you check element X, we are having 2 electrons. That's an alkaline earth metal, group 2 elements. So we're going to say alkaline earth metal. If they could have asked us that of Y, we could have said halogens or the halogens. Okay, question number 20. We are told use the information below to answer the questions that follow. That's how, the information that we are given. So we have carbon reacting with oxygen, giving us carbon dioxide. We are going to have the standard heat of reaction for this carbon dioxide will be negative 393 kilojoules per mole. Hydrogen gas reacting with a half mole of oxygen gas, giving us 1 mole of water. This will be the standard enthalpy of formation of water to be negative 286 kilojoules per mole. And we are going to have here the hexane gas reacting with 6.5 moles of oxygen gas, giving us 4 moles of carbon dioxide plus 5 moles of water. We are going to get negative 2,877 kilojoules per mole to be the enthalpy of combustion of that hexane gas. So let's see how we are going to do it. So we are told calculate the molar enthalpy of formation of butane from these elements in their normal states. So we have to first of all draw the energy cycle diagram. This is how it will be drawn. We have carbon reacting with oxygen giving us the butane gas, and this is the enthalpy of formation of butane. So we have here carbon reacting with the oxygen giving us the carbon dioxide, hydrogen reacting with oxygen to give us water, then that butane reacting with oxygen giving us carbon dioxide and water. So you have to balance the equations. If you check this equation here, enthalpy change 1, we have 4 moles of carbon, 4 moles of carbon. We have 8 moles of oxygen, even we have 8 moles of oxygen. Here we have 10 of hydrogen, we have 10 of hydrogen. We have here 5 atoms of oxygen, because by 2 we get 5 atoms of oxygen. This is 5 atoms of oxygen. Here we have 4 of carbon, that's the 4 of carbon. We have 10 of hydrogen, this is 10 of hydrogen. If you check the oxygen here, it will be 13 oxygen, because this is 13 over 2, by 2 we get 13 atoms of oxygen. If you check here, this will be 8 plus 5, that will be 13. So when I was writing the expression, I didn't check how the expression is given in the question. Check here. We are told the one for carbon dioxide is enthalpy change 1. The one for hydrogen producing water will be enthalpy change 2. The one for combustion of butane will be, they say, enthalpy change 3. So me, I've not done it like that because I've not checked it. So I've just made enthalpy change 1 to be the one for formation of carbon dioxide, the one for formation of water to be enthalpy change 2, which is correct even on the question. Then the demand question or the demand equation, I've make it enthalpy change 3, and the one they make it enthalpy change 3, I've make it enthalpy change 4. Okay, so this is the expression. There are 2 ways for us to get water and also carbon dioxide, or carbon dioxide and water. Those 2 ways is one way taking enthalpy change 1, adding enthalpy change 2, or going for enthalpy change 3, then adding enthalpy change 4. Both 2 ways will bring you carbon dioxide and also water. So we said enthalpy change 1 plus enthalpy change 2 will be equal to enthalpy change 3 plus enthalpy change 4. Let's put the expression. So here we have 4 in bracket, negative 393. Negative 393 will be the enthalpy of formation of carbon dioxide here. And if you check, we have only 1 mole of carbon. So, but when you check our equation, we have 4 mole of carbon with 4 mole of oxygen with 4 mole of carbon dioxide. So that's when we have to put 4 in bracket. We write the standard enthalpy of formation of carbon dioxide value, which is negative 393 kilojoules per mole, plus the side for hydrogen. It was only hydrogen, 1 mole of hydrogen reacting with half moles of oxygen gas, giving us 1 mole of water. So we have to multiply by 5 and write the standard enthalpy of formation of water there. Will be equal to enthalpy change 3, which we don't have in our case. That's the enthalpy change for the formation of butane. Plus, then we write the enthalpy change 4, which is the combustion of that butane, which we are given negative 2,877 kilojoules per mole. So when you put these ones on the calculator, we get negative 3,002, which will be equal to enthalpy change 3 minus 2,877. If you want to get enthalpy change 3, which is the standard enthalpy of formation of butane, we are going to say negative 3,002 plus 2,877 kilojoules per mole. So we are going to get negative 125 kilojoules per mole. We are going to go to question number 21. So in question number 21, we are told, part A, Romeo 1, a student found a colorless liquid in the laboratory, which he suspected to be water. Describe a chemical test that could have performed to confirm that the liquid is water. So we have 2 chemical tests. One is the use of anhydrous cobalt 2 sulfate. The other one is the use of anhydrous cobalt 2 chloride. So I said add drops of the colorless liquid into anhydrous cobalt 2 sulfate. It turns from white to blue, confirming the presence of water. Then number 2, what we can do is we can add drops of the colorless liquid into anhydrous cobalt 2 chloride. It turns from blue to pink, confirming the colorless liquid is water. That's why we're having 2 marks. Then Roman 2, we are told what other test could he have done to prove that the liquid is pure water? We are talking here pure. When we're talking about the purity of the substance, you have to check the melting and the boiling point of that substance. So we have water, so we have to check its boiling point. So we're saying boil the water in a beaker, measure the temperature. When the water starts boiling, pure water boils at 100 degrees Celsius at sea level. In question 22, we are told the diagram below shows that the setup that was used to prepare and collect a sample of nitric acid, nitric 5 acid. So we have potassium nitrate and sulfuric acid. So here we have cooled water. Here we have the nitric 5 acid. We are heating the reactants, potassium nitrate and sulfuric acid. So the first question, part A, we are told, give a reason why it is possible to separate nitric acid from sulfuric acid in the setup. So we're saying nitric acid has a lower boiling point, that's 83 degrees Celsius, than sulfuric acid or sulfuric acid with 337 degrees Celsius. Hence, during the distillation process, nitric 5 acid distills off first, leaving sulfuric acid behind. So, but B, we are told, name another substance that can be used instead of potassium nitrate. That's sodium nitrate. So, Roman C, we are told, give one use of nitric acid. Nitric acid has a lot of uses, several uses. I've written only 4. 1, manufacture of fertilizers, manufacture of dyes and drugs, manufacture of explosives, purification of metals such as silver and also gold. So you're asked to only state 1. I have given you 4. So question number 23, we are told the structure of water molecules can be represented as shown below. So this is how it looks like. So this is water. So this is 1 mole of water. This is another molecule of water. I mean this 1 molecule of water, another molecule of water, another molecule of water. So the atoms of water is hydrogen and oxygen. So that means oxygen and hydrogen are held together by this bond W, and this is another bond. So that means we are saying the atoms of water are held together by strong covalent bonds. But we said the molecules of water themselves are held together by van der Waals force. I mean, are held together by hydrogen bond, not van der Waals force. So this is another molecule of water. So this molecule of water and this molecule of water, we're having here a bond X. This bond X is hydrogen bond. What is a hydrogen bond? A hydrogen bond is an intermolecular force of attraction. So we're saying hydrogen bond is an intermolecular force of attraction in which the electropositive hydrogen atom of one molecule gets attracted to an electronegative atom, in our case oxygen atom or oxygen ion, of another molecule. That's another molecule of water. So this is hydrogen bond. So we're going to see what? So question number 23, Roman 1, we are told name the bond type represented by letter X and W. Letter X is the one for hydrogen bond, as you see here. X is hydrogen bond. Then W is covalent bond. W is covalent bond. Next, we are told Roman 2, relative molecular mass of methane and water are almost similar. However, the boiling point of water is 100 degrees Celsius, while that of methane is negative 161 degrees Celsius. Explain. So here, they are asking about the bond in those 2 molecules. So we're saying water has hydrogen bond, whereas methane has weak van der Waals forces as it is intermolecular force. Therefore, hydrogen bond is stronger than weak van der Waals force. Number 24. We are told diamond and graphite are allotropes of carbon. In terms of structure and bonding, explain why, Roman 1, diamond is used in drilling of hard rocks. We are saying this is due to its hardness. Roman 2, graphite is lubricant. Reason is due to its high melting point and it is slippery in nature. We go to question number 25. We are told the setup was used to prepare dry hydrogen gas. Study it and answer the questions that follow. So if you check, we have hydrochloric acid reacting with zinc granules. So we are having through a delivery tube taking the gas, and it's taken to liquid Y, which is the drying tower, in the drying tower or drying agent, liquid Y, and the gas is collected by downward delivery tube. Remember, hydrogen is less denser than air, so we expect it to be collected by upward delivery tube. So the first question they are asking us is the setup used to prepare the gas correct? We are told give a reason. So the answer is it is not correct, isn't it? Yeah, so we're saying it is incorrect. Why is it incorrect? Because we are saying of the use of wrong method of gas collection. The gas collection they have used is downward delivery tube. It was supposed to be upward delivery tube. So the setup is not correct. So in Roman 2, we are told what will be liquid Y. Liquid Y, we said it's the drying agent, concentrated sulfuric acid. Okay, Roman 3, we are told give two uses, or I mean two physical properties of hydrogen gas. One, it's colorless and odorless gas. Roman number 2, it's less denser than air. And number 3, we have it is slightly soluble in water. We go question 26. We are told given element W has atomic number of 14 and consists of isotopes as shown below. So the isotope A, B, and C. Isotope mass 28, 29, 30. Percentage abundance in 2.2, 4.7, and 3.1. Determining the relative atomic mass of W, the Rm of W. Rm is calculated by mass number 1 multiplied by percentage number 1 plus mass number 2 multiplied by percentage number 2 plus mass number 3 multiplied by percentage number 3 divided by 100. So mass number 1 is 28 multiplied by 92.2 plus 29 multiplied by 4.7 plus 30 multiplied by 3.1 divided by 100. So if you put the numerators in a calculator, we are going to get 2810 then we have divided by 10. We are going to get our relative atomic mass to be 28.109. Remember, relative atomic mass has no unit. So we got 27. Question 27. We are told the diagram below represents a setup used for a large-scale manufacture of hydrochloric acid. That's the setup. Here we have dry chlorine gas, and we are having hydrogen, which is taken in a jet. So we are told name substance X. That's hydrogen gas. hydrogen gas. So in part B, we are told what is the purpose of the glass pads. This is the glass pad. Down here, we were having dry chlorine gas and also hydrogen gas. Then hydrogen chloride gas comes here. Then we are dissolving water over glass pad. So what is the role of the glass pad? We are saying to increase the surface area for the dissolution of the gas, for the dissolution of the hydrogen chloride gas. That's what we mean. So but C, we are told give one use of hydrochloric acid. One, we said used in treatments of water. Number 2, we have written used in making dyes and drugs, just like nitric acid. So you are required to only state one. Number 2 is 28. So I told a mixture contains iron 3 chloride, calcium chloride, and iron fillings. Describe how one can separate and recover the substance in the mixture. 3 marks. So we are having iron 3 chloride, which is a sublimate, or which can undergo sublimation method. We have calcium chloride and iron filling. Iron filling, we can use a magnet to remove it. So the first step, we have to pass the mixture, a magnet over the mixture or in the mixture. So you're saying pass a magnet in the mixture. So iron filling gets attracted to the magnet because iron filling is magnetic. So it attracts a magnet, leaving calcium chloride and iron 3 chloride behind. Okay, after that, we have to put the iron 3 chloride and also calcium chloride in a beaker. So you're saying heat the remaining mixture in a beaker, and that beaker will be covered with a watch glass containing cooled water or with cooled water. So when we heat the mixture, what will happen when we heat the mixture of calcium chloride and iron 3 chloride? That means iron 3 chloride sublimes. That means it will be, we are saying iron 3 chloride sublimes and is collected beneath or on the cooler part of the watch glass. That's what else we can say. Then what will happen to calcium chloride? The calcium chloride remains in the beaker. It will be remaining in the beaker. So question number 29, the last question. We are told the structure below represents two cleaning agents, A and B. Which cleaning agent will be suitable for washing in water containing calcium chloride? Give a reason. What's calcium chloride? Calcium chloride is just it's having calcium oxide, so when it's added to water, it makes the water hard. So calcium chloride contains calcium ion, which is responsible for water hardness or hardening water. So here we have cleaning agent A and cleaning agent B. So this one is having sulfonate and this one is having carboxylic. So that means this will be soap detergent or soapy detergent, and this one is soapless detergent. So between soapy detergent and soapless detergent, which one is used for cleaning with the hard water? It's soapless detergents, because we are told the compound that we are going to get will be just soluble in the water. Okay, we are saying A. The answer A. Why? Because it's soapless detergent, hence it does not form scum. But if you use with B, which is soapy detergent, it forms scum, because soap or sodium stearate will react with the soap. Will react with the soap to form scum. Will react with the calcium ion present in the hard water to form scum. Okay, that is the last question for this PP1 production. Thanks for watching. Thank you.